Hello, this is Hands-On Infrastructure Automation with Ansible. This is Section 6, Storing Your Project Files in the Vault. In this section, we will look at Ansible Vault, its purpose, how it works. We'll look at using Ansible Vault to encrypt and decrypt files. We'll look at creating files that we can use for Vault that store passwords, so that we don't have to type the password in every time we use Vault. And so we'll talk about how to generate those passwords securely. And we'll talk about using Vault not just for files that have variables that we want to keep secret, but also encrypting files that will be delivered to the remote system. Ansible Vault purpose. In this video, we'll look at storing Ansible roles and playbooks into a version control tool, such as Git. We'll look at ways to manage secrets. Once we have our Ansible data in version control, we'll have passwords and other secret information that we'll want to maintain, and we'll talk about how to do that. And we'll talk about Ansible Vault and how it solves that problem of maintaining and managing secrets when we have Ansible data that is checked into version control. When we talked about some of the advantages of Ansible and exactly how it works, we said one of the big advantages is that it lets us capture information about how to install and configure software in a plain text format, specifically in the YAML file format. And we said that an advantage of that file format is that it's very easy to read, it's easy to understand, it's simple. One of the advantages that comes out of that is that it is a perfect fit for a version control tool. It becomes very easy to take those plain text YAML files, check those into a version control tool like Git, share them across a team, and then everyone can see as those Ansible YAML configuration files are updated over time, they can see what changed. They can review those changes, using the Git online tools. It becomes very easy to collaborate as a team doing work with Ansible. Just to illustrate that, I'm going to skip over to a tool called Atlassian SourceTree. SourceTree is a Windows and Mac user interface for Git. What it does is it provides you with a way to look at a Git repository. It also works with Mercurial, and it shows you the history of all the changes that have been made and committed to that repository. And you can see how it's very convenient to look back at the history. You can see over time exactly what changed. And then for every one of these changes that I've made to our .cms repository, you can see the exact files that were changed. You can see a reason, a description of the commit, and then you can see the actual changes that were made. So you can see in this case, this change to this Java role involved me adding this new task in order to configure a Java home directory. So you can see exactly the files that were changed as a result of this commit to the version control repository. So that's really convenient, and it's really one of the benefits of Ansible is that I'm storing all of this software installation and configuration information in these multiple files, multiple small files in a simple plain text format. It makes it much easier to work with a version control tool than if you have, a few large scripts, which is much harder. I don't even need Atlassian SourceTree. It's a nice tool, but a lot of this work I can do directly in my Atom editor. So you can see here that I have a basic file. It does some updates to a database. This is one that we looked at in a previous section to install and configure Postgres from a single playbook. And you'll notice that when I make changes, Atom will notice that this file needs to be committed to the Git version control repository. It turns it yellow to show that it has changes. It marks the line that I've made changes to. And then over on the right-hand side, you can see it show up as an unstaged change. And I can actually commit this change to Git directly in this repository. And then I have to stage it and hit commit. And just like that, I've made a new change to the version control repository. So it's a very nice flow. It's very easy to do that directly in the Atom integrated development environment. But now that I've done that, it raises an important question. I'm storing a password here. It's the password that will be used by this Postgres user in order to access the database and store data and retrieve data. that's probably not something that I want to share externally. And one of the purposes of a Git version control system is to be able to push the changes to a remote server so that they're backed up. I don't necessarily want to keep a secret in this form, or, at least I want to think about exactly what does it mean to have this password stored in this file and then checked into a version control tool and then potentially put up on a remote server where other people can access it. So I need a way to manage those secrets. So let's look at a few possibilities. One is I can do what you saw right here. I can just store the password right in my Ansible playbook or an Ansible variable file. I can store it in the clear, is the term that's used, so I'm not using any kind of encryption. That is certainly the simplest. It's a very simple way to do it. But it means that anyone who can access that repository, either on my system or on the remote server, has access to all of those passwords, all of that secret information. So that might not be the most secure approach. The second approach I might take is Git supports the concept of an ignore file. You can tell it, hey, certain files should not be checked into version control. And so I could put my password in a variable file that just has passwords in it. And then I could tell Git not to check that file in, not to include that file. Now that is safer, but I have to do extra work now. If I have multiple people on my team, I can't use Git anymore to distribute this information to all of them. I have to use some other mechanism. So really, I would prefer a solution that let me check it into version control, but still kept it safe. And that's exactly what Ansible Vault does. Ansible Vault allows me to take a file, usually a variable file that has a bunch of passwords in it, and then I encrypt it using some password. Once that file is encrypted, it's perfectly safe to check it into version control. And then at this point, the only thing I need to distribute is just one password. And anybody that has that password can use Ansible Vault to decrypt the file. And when we run Ansible, we run the Ansible playbook command or the regular Ansible command, and that Ansible needs content from a Vault encrypted file, Ansible will use that password to decrypt the file transparently, so that I don't even have to tell Ansible to decrypt the file explicitly before I use it. I can just leave it in its encrypted form, provide Ansible with the password. It gets decrypted transparently, but it doesn't get written out to the disk in a way that's insecure. So let's look quickly at an example of what an Ansible Vault encrypted file looks like. So we have our group variables. This is the all file within the group variables. You can see that, it doesn't really look like much. I can't tell exactly what the content is. This is actually a set of Ansible variables. It includes a secret information, it includes a database password. But from the perspective of what gets checked into version control, what goes into version control and what someone that accesses this repository would see would just be this string of numbers of this encrypted file. And Ansible is using, this is the standard of the encryption that it's using, AES 256, which is a symmetric key encryption. It's a good standard for encryption, so Ansible is keeping this content very secure. So this is a real advantage because it gives me the ability to still have these secrets recorded, have them checked into and saved in the version control tool, but not visible to anybody unless they have the password to do the decryption. So that covers our view of Ansible Vault and what it's designed for.